Hello everybody. Now we are going to solve this problem. This is coming under analog electronics and fixed bias circuit. VBE is equal to zero point 0.7 volts, then only it gets activated. So in order to solve this, we consider the input side. So for that we have to write input side KVL equation, Kirchhoff's voltage law. By applying KVL, we can write equation at the input side. So it starts from here actually. The 12 volts, then the current flows through this path, and it enters here. This is the path. So I can write it like, so I can write the equation as VCC minus IBRB minus this voltage drop is there, right? So minus VBE, that is equal to 0. So you must be getting and some idea on this. How we actually write, how do we write? We start from this point. So the current starts flowing from this higher potential of plus 12 volts. It is flowing through this resistance RB and it is entering into the base. After that, it is leaving this emitter emitter point. Okay, and it reaches the ground. Between these two, you are now having the VBE as the potential drop, and you know that value is given as 0.7 volts. Yeah. So in this particular equation, you can substitute the values like 12 minus IB value is given, it is 20 microamps, so 20 into 10 power minus 6, and RB value is not given, that is what we are going to find out. So RB minus this VB value we know, so that is equal to 0. So I can write it like 12 minus 0.7 is there, so it is 11.3 minus 20 into 10 power minus 6 RB, that is equal to 0. So we can write it like minus 20 into 10 power minus 6 RB, that is equal to minus 11.3. So cancelling this minus and minus, then you can find out this RB is equal to 11.3 divided by 20 into 10 power minus 6. So this is equal to 0.565 into 10 power. When you bring this to the numerator side, it becomes 10 power 6. So I can write it like, if you bring this to this side, 3 digits, then I can write it like 565 into 10 power. So RB is equal to 565 kilo ohms because it's a resistance. So we got one answer. Then I go here to find out IC, right? IB is already given. So we can immediately find out IC also, right? Because the formula is IC is equal to beta times IB. That is one formula, the standard formula we can use. In that IB is given. So IC is equal to beta is also given in the problem here, like 80. So that is 80 into that IB is 20 microamps. So it is 10 power minus 6. 80 into 20 is 1600 into 10 power minus 6. So I can write this like, now the point is here. If I bring the point here, then it becomes 1.6 into 10 power minus 3. So IC is equal to 1.6 milliamps. So this is another answer which we need, that we found out. So one more thing we need to find out, that is two more parameters we need to find out now, RC and VC. For that we can write the output side equation, output side KVL equation. So what is that output side actually? So the current will also flow through this path plus 12 volts, then RC through this collector emitter junction, and then finally it ends at the ground. So we write the equation for this, that is VCC minus ICRC minus VCE, that is equal to 0. So in that, if you substitute the values, it is 12 minus IC is 1.6 milliamps, so it is 1.6 into 10 power minus 3 into RC value we don't know, minus this VCE value, that is equal to 0. And so you should know the value of VCE, then only you can find out this RC value, isn't it? because in this equation you have this RC and VCE value as unknown value. So we have to calculate this VCE to find out RC. So VCE is voltage across this collector to emitter terminals. So it is the double subscript here we have. It can be written using single subscript as VC minus V. In that VC value is given as 6 volts, right? So you can write this VC as 6 volts minus, what is this VE? VE is this emitter voltage. So it is directly connected to ground only. Because of that, VE is equal to 0. So VCE is nothing but that VC value. So it is 6 volts only. So once you know this value, you can substitute this value in this VCE in that equation. So that you will be getting it as 12 minus 1.6 into 10 power minus 3 RC minus 6, that is equal to 0. So it becomes 12 minus 6 is 6, 6 minus 1.6 into 10 power minus 3 RC is equal to 0. So I can write it like minus 1.6 into 10 power minus 3 RC. That is equal to, when you bring it to the right hand side, it becomes minus 6. But this minus sign we can cancel out. So it is 1.6 into 10 power minus 3 RC is equal to 6. So RC is equal to 6 divided by 1.6 into 10 power minus 3. So for that you do the calculation. 6 divided by 1.6 is equal to 3.75. So it is 3.75 into 10 power 3 when you bring this to the numerator. So RC is equal to 3.75 kilo ohms. So we got all the answers now. So when you summarize this answers, first we know what is RB value, and we have to write RC value, we have to write IC value, and we have to write the VCE. RB is 565 kilo ohm, and this RC value is 3.75 kilo ohm. IC value is 1.6 milliamps, and this VCE is nothing but VC, so it is 6 volts. So these are the answers we got. Okay. Hope you have understood this problem as how to solve. Thank you.